We live in a world where every creature sees through a unique lens that is evolved for their habitat, perceiving the world in ways vastly different from our own. In contrast, robotics today often relies on sensors that are generic and not optimized for specific applications such as odometry and depth estimation. Taking inspiration from nature, we propose a novel method called CodedVO or coded visual odometry. Let us first understand how the aperture in the camera works. The aperture is like the camera's pupil, adjusting to control the amount of light entering the lens, inducing blurs at different distances. Traditional monocular cameras suffer from scale ambiguity, and hence existing methods have their limits in metric depth estimation. In this work, we leverage a transparent thin plate or coded aperture that modifies how light enters the camera, creating unique blur patterns at different distances. Introducing a controlled blur pattern in the image enables us to predict metric depth information from a single RGB image. To train our depth estimation network, we first simulate the coded image using a sharp RGB, a ground truth depth image, and the point spread function. Then we train our unit metric depth estimation model by employing a novel depth weighted loss. Since odometry estimation heavily relies on the accuracy of feature correspondence, emphasizing depth information at closer pixels leads to more accurate odometry estimation. Notably, we utilize only 2000 images from NYU V2 and UMD CodedVO datasets for training our model that not only generalizes to novel scenes but runs at 858 Hz on an NVIDIA 4090 GPU. We successfully evaluate the performance of our method on unseen odometry datasets and existing indoor navigation benchmarks. Despite the lack of high-quality depth images, our depth method achieves state-of-the-art metric monocular visual odometry. The plug-and-play nature of CodedVO allows easy integration into any existing visual odometry frameworks, enhancing their performance by reducing the need for additional sensors. By adopting these nature-inspired apertures, we can enhance the robot perception capabilities, tailoring them for specific tasks and environments. Thank you for listening.